Welcome on this tutorial. Wish all you are well. In this series of PLC tutorial, I am going to discuss about ladder diagram. What is ladder diagram? How it looks? What are the different parts of ladder diagram? How contact and coils function as inputs and outputs in ladder diagram? What are the different rules to be maintained while representing a program in ladder diagram? Entering into the discussion, please subscribe. This is the only return from you to me, and it will encourage me to upload more and more important tutorials. Ladder diagram is a graphical programming language that uses a series of rails and rungs containing logic symbols that are combined to form decision-making expression. It is composed of two vertical power rails. This is one, this is another, and horizontal logic rungs to form what looks like a ladder. Ladder logic is most commonly used PLC programming language, and it is also called relay ladder logic. Control logic in the ladder diagram is contained within the rungs. Ladder diagram are to be thought of virtual circuit consist of virtual power, virtual contact and virtual relay coils. Here the power flows, which is normally virtual, this is not actual. There are contacts and coils. These are the representation of actual field devices. The rails in the ladder diagram represents the supply wires of a relay logic control circuit. There is a positive voltage supply rail on the left hand side and a zero voltage rail on the right hand side. In a ladder diagram, the logic flow is from the left hand rail to the right hand rail always. This is a ladder diagram, and here all the parts in the ladder diagram have been described. First one is rails. There are two rails in the ladder diagram which are drawn as vertical lines running down farmost ends of the page. This is one rail, this is another rail. If they were in the relay logic circuit, they would represent the active and zero voltage connection of the power supply, where the power flow goes from the left hand side to the right hand side always. Next, rungs. The rungs are drawn horizontal lines and connects the rails to the logic expression. This is rung 1, this is rung 2, this is rung 3. This connects the rails to the logic expression. This combines the logic expression. If they were in the logic circuit, then they would represent the wires that connect the power supply to the switching and relay components. This output corresponds to coil of the relay, and this contacts corresponds to different contacts of the relay or different input devices. Next, inputs. The inputs are external control actions such as a push button being pressed or a limit switch being triggered. The inputs are actually hardwired to the PLC terminals and represents the ladder diagram by a normally open contact or normally closed contact. Outputs. The outputs are external devices that are being turned on or off, such as an electric motor or a solenoid valve. The outputs are also hardwired to the PLC terminal and are represented in the ladder diagram by a relay coil. This relay coil represents the physical output, which is ultimately to be activated with respect to different logic expressions or different logic conditions. Logic expression. The logic expressions are used in combination with inputs and outputs to formulate the desired control operations. So, the combination of all these inputs and outputs are ultimately define a particular logic expression which are required for the control and operation of the process. Addressing system or tag. Every inputs and outputs must have the addressing system as well as the tag. The addressing notation describes the input, output and logic expression memory addressing structure of the PLC. The tag name are the description allocated to the address. So, this address or tag name ultimately defined a particular memory location where the status of input and outputs are defined. Comments. Comments are an extremely important part of ladder diagram. Comments are displayed at the start of each rung and are used to describe the logical expression and control operation that the rung or group of rungs are executing. Here see, the comments for rung 1 means what is the purpose of this rung or what the rung will do, that is described in comments. So this comments for rung 1, for this rung 2 we may write the comments here, for this rung 3 we might write the comments here. So understanding ladder diagram is made a lot easier by using different comments. Contacts and coils in ladder diagram. These contacts and coils are most important part in ladder diagram. The most elementary objects in ladder diagram programming are contacts and coils, which is intended to mimic the contacts and coils of electromechanical relay. The physical relay, no doubt, having coils as well as the contacts. In ladder diagram, the outputs are the representation of the coils of actual relay device. Here this is one contact, this is another contact, and this is the relay coil. Here this is the input, and this is the output. Now these contacts and coils are discrete programming elements dealing with Boolean variable states. Means either logic 0, logic 1, off or 1, false or true. These are the different states. Each contact in ladder diagram program represents reading of single bit from the memory, whereas each coil represents writing of single bit into the memory. Say here in this case I 0.1 represents a particular input device. This is input register, means memory location, and each bit of this memory location is the representation of states of the input devices. Say a input device having address I 0.1 and the states of this device means whether it is giving the logic 0 or logic 1 signal. That logic 0 or logic 1 signal is at the second position of this input register. So when this is activated or from the physical side the logic 1 signal is coming, then here the second bit will set as logic 1. Similarly, these are the other single bit memory location corresponds to different input devices. Now say this is output register. It is having 8 bit memory location. Each bit represents output status. Means according to the different input conditions, what will be the ultimate output, whether it will be 0 or 1, that will be written into the corresponding memory location. Say Q 0.0, when this Q 0.0 will be logic 1, then at the first bit position a logic 1 will be placed here. If Q 0.0 is logic 0, then the first bit will be reset to 0. So this ladder diagram contacts are the representation of real world discrete input signals to the PLC. Each discrete input channel has a specific address and tag name which must be applied to the contacts within that program. Similarly, discrete output channels referenced by coil symbols must also bear some form of address or tag label. Say I 0.1 is the address of a particular input device which is represented by this contact. I 0.2 is address of another input device which is represented by this contact, and Q 0.0 is the address of a particular output device which will be operated with respect to the condition of this Q 0.0. These contacts and these coils are normally virtual, means this is not actual, this is the representation of actual devices. Each virtual contact shown in the program actuates whenever it reads a 1 state in its respective bit and will be at rest whenever it reads a 0 state in its respective bit in PLC's memory. See, this is the input states of different input devices. From where these states are coming, these are the physical status. states of different input devices, whether it is 0 or 1, means according to the 0 or 1 signal from the device, the memory location is set as 0 or 1. According to this contact is either energized or de-energized. How this contact will behave means whether it will be connected or disconnected, that will depend on the 0 and 1 states in the corresponding memory location. Bit state might be 0, might be 1. Contacts are normally two types of contacts. One is normally open contact, another one is normally closed contact. Normally open contact is having only two vertical lines, and normally closed contact is having extra slash in between two vertical lines. Now, when the corresponding bit is 0, then the status will be as it is. Means when the bit is at 0 state, the normally open contact will be open and normally closed contact will be closed, means both will be as it is. But when the logic 1 will come from the field, then this normally open contact will behave as a closed contact and normally closed contact will behave as a open contact. In this configuration, by using this red colored shade indicated that the contact is closed, means there will be a direct power flow through this contact. So when 0 will come from the field, then the contact will behave as it is, means normally open will be open, normally closed will be closed. But when a logic 1 signal will come from the field, then the normally open contact will behave as a closed and normally closed contact will behave as a open contact. When 0 will come, the contacts will be at normal situation, and when 1 will come, then the contacts will be in actuated nature. So if the contact is normally open type, it will be open when its bit is 0 and closed when its bit is 1. If the contact is a normally closed contact type, it will be closed when its bit is 0 and open when its bit is 1. A 0 bit state causes the contact to be in its normal or resting condition, while a 1 bit state actuates the contact, forcing it into its non-normal or actuated state. The programming software offers color highlighting to display the virtual status of each program element. A colored contact is closed, while an uncolored contact is normally open. Colored contact is a closed contact. Colored are either normally closed contact with 0 bit states or normally open contact with 1 bit states. Virtual contact inside the PLC program are thus controlled by their corresponding real world switches. Say here 1 to 6 are 6 numbers of input terminals at PLC, and these are the different states from the field. First one produces logic 0, second one logic 1, third one logic 0, fourth one logic 1, fifth and sixth are giving logic 0 signal from the field. Here 2 and 4 are giving logic 1 signal, so 2 red colors indicates that logic 1 signal is coming from the field. Now what will be the nature at the ladder diagram? See here X2 has been used in 2 position. Here X2 is with normally closed contact, here X2 is with normally open contact. Here X2 is having red colored, but here X2 is having no red color. Red color indicates that it is acting as close contact. Now how here it is a close contact? See, from the physical field a logic 1 signal is coming. So when logic 1 signal is coming, then this close contact will act as an open contact and the open contact will act as a close contact. This is normal behavior. When a 0 signal will come, then the status will be as it is. See X1, a 0 signal is coming. Here this is X1, that was open contact. As the physical device gives logic 0 signal, so here X1 is open contact, so it is behaving as a open contact. See, I am taking another example. See X6. What is the nature of X6? From the field a 0 signal is coming. So when 0 signal is coming and X6 here is used as normally close contact, so it will behave as a close contact. As this is close contact, so it is indicated by red color. So according to the physical status means according to the status of the physical devices, whether it is logic 0 or logic 1, in the ladder diagram contacts will be logic 0 or logic 1. Whether a particular contact will behave as a close contact or open contact, that will fully depend on the states or status of physical devices, means whether the physical devices is producing 0 or 1. Another point, the status bit in the input register will be set or reset according to the status of the physical devices. See here, x1 is having 0, so see x1 is 0, x2 is 1, x2 is 1, x3 is 0, x3 is 0, x4 is 1, x4 is 1, x5 is 0, x5 is 0, x6 is 0, x6 is 0. How ladder logic works? Ladder logic basically works just like if-then relation. This is a very simple program. This is one input with normally open contact. This is output. This works like that. If input A is logic 1, then output Y will be logic 1. Means this output Y will be activated. This green color indicates the power flow. Say this is input, this is output. If A is false, means this is logic 0, output is logic 0. If A is true, means this is logic 1, output is logic 1. Means this input will act just like a short circuit and there will be a power flow through this output, means output will be activated. Few rules to design ladder diagram programming. Inputs in ladder diagram can be used in series as well as parallel to form a connection. See here, I 0.0, 0.1, 0.2, these are connected in series. Here, I 0.0, I 0.1, I 0.2 connected in parallel. Outputs or coils can be used only in parallel. See, Q0.0, Q0.1, Q0.2 are connected in parallel and normally outputs are placed at the right hand side of the rung. Never any output can be used in series. One input can be used in multiple times in one program. Say a particular program having many numbers of rungs or network, then a particular input might be used in several positions. In this example, say here in this rung I 0.0 has been used. In this rung I 0.0 has also been used. One output cannot be used multiple times in one program except in set, reset and latch or unlatch function. Means a single output can never be used in two positions unless it is used in set, reset or latch unlatch function. Here Q0.1 has been used as a set coil and Q0.1 has been used as a reset coil. Means Q0.1 has been used in two positions while it is used as set and reset. But never that Q0.1 is allowed to be used in series or parallel in anywhere else. I told that a particular output can be used only while it is used in set, reset as well as the latch unlatch function. In this case, see, Q0.1 has been used here as well as has been used here. This is used for latching operation. In previous tutorial, I have explained what is latching operation. Input address cannot be used as an output address. Means this is the output which will be addressed by Q0.0. Means it is addressed with a letter Q. Never we can start the output address with English alphabet I. Input address can never be placed at the position of output, means at the position of the coil, but output address might be used at the position of input. See here, this is the input contact and the address is Q0.0 and this is permitted only for latching operation. So in this tutorial we came to know about the ladder diagrams, how to draw the ladder diagram, what are the different parts like rails, rungs and different instructions, how contacts and coils behave in the ladder diagram, what will be the nature of the contacts when those will be activated or deactivated according to the field device's status? What are the different rules should be maintained when we will write PLC programming in ladder language? In next tutorial, I will discuss how we can explain different logic gates by using ladder diagram. Be with me, subscribe, put comments and queries in comment section.